Hello everybody, welcome to your first introductory class in mathematics of class 11th. Let me make it very clear that I would not be covering your maths syllabus for class 11th. I will be taking just a few introductory sessions and occasionally one odd topic in the future. Your subject mathematics will be covered by the mathematics experts, and some of them will be taking the basic boards and some of them will be covering some of the multiple choice type questions and higher order questions which will be useful for your preparation for entrance examinations such as for JEE and so on. So with that as a clarification, let me start this introductory session. Today we will be starting with a topic which is completely new. In other words, it is a part of algebra which you have never been introduced to up to 10th standard at all. Many other parts, somewhere or the other, you would have had a basic introduction. But there are some of these topics such as calculus, which you will be coming across with a little later down in the year, and complex numbers over here, which is completely new. On the other hand, some topics like statistics, probability, and so on. Some introduction you have already had, coordinate geometry. Some introduction you have already had somewhere or the other. In 11th standard, you will be building on that foundation which you have done in 10th standard and moving further. But some of these topics, as I said, would be a completely new topic. Now, having said that, let's try to understand what complex numbers are. To see complex numbers in a correct perspective, we will take one example. We will take the example of a particular word problem to understand what complex numbers are. So, let me put forward a word problem for all of you. Suppose I ask you, I have in mind a particular number which, when it is squared, gives me the number 9. So let me repeat this question. I have in mind a particular number, say x, which when squared gives me the number 9. What is the number I have in mind? Now, you say, as I have already said before, that let the number be x. So, putting this word problem into an equation, converting it into an equation, we can say that according to the condition given, the number when squared gives you 9. So we can put it as an equation, x squared is equal to 9. So what is the number? Take roots on both sides, taking root on the left hand side and on the right hand side. I can say x is equal to square root of 9, which happens to be, suppose you say 3. Not wrong at all. I say, can it take some other value? And I'm sure you'll think a little more and you'll say, it could be plus 3, it could also be minus 3. Very much possible, because plus 3 into plus 3, that is plus 3 square, is equal to 9. But equally correctly, minus 3 into minus 3, 3 3s are 9 and minus into minus you know is positive. So minus 3 into minus 3 is also 9. And so to be more correct or more accurate about our answer, we can say that the value of x should be either plus 3 or minus 3. Both would be correct possible values for the number I have in mind. Now, let me change this question a little, and suppose I say, I have in mind a number which when squared gives me minus 9. Now, how will you answer this question? So, I have a number in mind x, which when squared gives me minus 9. And you try to think of an answer to this question, and you will find it's very difficult, because to obtain minus 9, when you square a number, you have to multiply it by itself. That is what we call as squaring a number. So suppose if I try to put plus 3 into plus 3, I get 9. not minus 9. If I take minus 3 into minus 3, again I get 9 and not minus 3. With 3's, if I have to get minus 9, I would have to take plus 3 into minus 3, and that will definitely give me 9. But this is not called squaring. So this is not the square of these, either of these numbers. It is neither minus 3 square nor is it plus 3 square. Then what exactly is, oh sorry, this will give me minus 9. That's quite right, but this is not squaring of this. You are multiplying two different numbers. You are taking plus 3 and multiplying it by minus 3. You are not multiplying it by itself. You are multiplying it by a different number. That is not called squaring. And so you cannot say that minus 9 is plus 3 square, nor can you say it is minus 3 square. So putting it mathematically, I would put it as plus 3 square is not equal to minus 9, and minus 3 square is also not equal to minus 9. So then what is minus 9 equal to? And try as much as I may scratch my brain, I will not be able to come to any logical answer to this. That is where we introduce a new concept called as an imaginary number. Now, what exactly do we mean by imaginary number? We mean that let the root of this be some imaginary number. Now, why are we calling it imaginary? We are calling it imaginary because outside of our imagination, and in your imagination you can imagine anything. You can imagine, I can imagine, for example, that I am very strong, heavily built. I can also imagine I am very rich. In your imagination, there is no limit. I may have nothing in my pocket, but I could still imagine I am very rich and I am sitting on a very nice plush golden chair or something like that. It's possible. Imagination में कुछ भी possible है. So वैसे ही imagine कि ऐसा कोई number है, and because it is not reality. Reality is I don't have that kind of wealth in my pocket. So it is not true. It is not real. And so it is not a real number. Now here we'll try to recall what you have studied in 10th standard as real numbers. We'll take a brief recap of the different kinds of numbers that we have studied, and then again see imaginary numbers in a new perspective. So for this, let's just quickly recap the type of numbers that you have come across in number systems so far. So somewhere way back in your earlier classes, you were introduced to certain numbers such as, just a minute, please let me take this marker, such as you started off with something called as natural numbers. We call these natural numbers because in nature, most of what you come across happens to be represented by these numbers. So natural numbers were numbers like 1, 2, 3, 4, and all the way up to infinite. These are what we call as the natural numbers. The collection of these natural numbers, taking them all together as a group, you can represent them as what we call as a set. The word set in mathematics simply means a particular defined collection, some kind of a order, some kind of a rule which defines what will be included. What is included in it is called as an element, and that kind we call as a set of that numbers. We represent that in curly brackets, and we name this particular as capital N. The set of natural numbers is the numbers 1, 2, 3, 4, and so on, all the way up to infinite. Now, somewhere you look around you, you'll come across in nature one apple, one mountain, one moon, and so on, or maybe two birds somewhere, or maybe 3 trees somewhere. By nature, you don't get spontaneously 2.5 trees. Everything occurs in a completeness. And so, when we use the word natural numbers, we use all these complete numbers. Devoid of fractions, decimals, no, we are not including these over here. Those will come by mathematical operations or by some procedures. You could take an apple and cut it and you will have half an apple. But in nature, on a tree, you are not going to get a half apple growing by itself. So in nature, you're going to get all of these like this. And all the way up to infinite. Difficult to count the number of stars. In fact, according to the recent advances, probably there are infinite universes. So we really don't know much about this at this point. But it can go all the way up to more than you can possibly physically count, which we just represent for simplicity as infinite. So all of this becomes the set of natural numbers. You make one important addition to this, the famous number which we always take glory to ourselves as India's contribution to the world, the number 0. You add that and you get what is called as the collection or the set of whole numbers, often represented as W, and this is then represented as 0, 1, 2, and so on, all the way up to infinite. Now, make one more important modification to all of this. This does not include negative numbers, but in mathematical operations, you can end up with negative numbers, and so we introduce what is called as a set of integers, which is sometimes represented as capital I, often also represented as capital Z. So that then becomes from minus infinite, from negative infinite, coming all the way to say -3, -2, -1, 0, then +1, +2, +3, and all the way going to positive infinite. That becomes the set of integers, as we call it. Now, to this, you start adding the numbers which fall between any of the two integers, such as, for example, 0.1, 0.2, 0.3, or say 1/2, that's half, 0.5, falls between these two. And you start getting what we call as the fractions or decimals and so on. And they can be very, very minute fractions. So you can have 0.00001 or something like that. And so we say that between any two of these, you can have infinite number of additional numbers which are small and smaller, even smaller and even smaller. All of these together, we now start calling as the real numbers. And we also introduce over here something as a number line, which is the geometrical representation of all these numbers. In other words, in the form of a figure, in the form of a diagram, if you want to represent these numbers, then we can take the help of a line, something like this. On this, you can represent a 0, you can represent a 1, you can represent a 2, and you can represent numbers between these. And if you magnify this, even between those, you magnify this and smaller still, and magnify this part and still smaller between these two, you make it into even smaller parts, and you can keep going on magnifying and introducing more and more points, because geometrically you have studied that a line is a collection of infinite number of points. So आप जितने मर्जी छोटा नंबर इसमें लीजिए, उसको कहीं ना कहीं एक corresponding point उस लाइन पे जरूर आ जाएगा. This way you start getting what we call as the set of real numbers, both on the positive side as well as on the negative side. And this you have done in 10th standard as well. You have taken a number line and showed that it can have any number of points in between. In fact, you probably may be remembering being asked questions like introduce or list 5 numbers in between 3.1 and 3.2, or between 7/11 and let's say 7/12, something like that. So, or maybe between 7/11 and 8/11. List some more numbers in between this, etc. So that way you can introduce all of these. That becomes your set of real numbers, which also is all the way from minus infinite to plus infinite, but also includes decimals and fractions. And just for representation purpose, using 0.5 alone, but this could actually be, as I said, any number of decimals in between. So literally infinite points or infinite numbers just between two given integers as well. And so you really get a line with absolutely unimaginably infinite number of points. We also studied that these real numbers, some of them may be a little difficult to give a pinpoint value to. So if you remember, in your earlier classes in secondary school up to 10th standard, you were introduced to something called as non-terminating, repeating numbers. So for example, take the number 10 divided by 3. This you know is 3.333, and this can go on endlessly. Now this kind of a number would be a little difficult to put on the number line, but we know that there are some kind of shortcuts or some kind of ways, but somewhere or the other there will be a point where this number would also be possible to be represented. And you also saw that any number which is like this, we often represent this, if you remember, as 3.3 with a bar on top, with a dash on top, to signify that this means it is non-terminating. It is going to keep on repeating forever. This kind of a number, the equivalent fraction of that, you did that as well. Now, apart from this, there were some numbers which were non-terminating and non-repeating also. So for example, if you take something like square root of 2, one of the easiest non-terminating and non-repeating numbers. Square root of 2 आप long division से करने जाओगे तो 1.4, and it can keep on going. You could go up to 100,000 million digits and it will still not show either any signs of repetition nor of terminating and coming to an end. The process will keep on going. And similarly, root 3, root 5, root 7, so many of these numbers, these you were taught are irrational numbers. So the set of real numbers got divided into two major classes: rational numbers such as, for example, 3 upon 2, or for example even 10 upon 3, which although non-terminating can be expressed as a ratio of two integers, and from that word ratio you get rational. So these were examples of rational numbers, these were examples of irrational numbers. Both collectively gave you the set of real numbers. This way you were introduced to a variety of different numbers so far. Now, to this real world, you add a new dimension which does not exist anywhere in reality. It can never be represented on any given number line. It's existing only in our imagination. If we are asked, show it over here, we can't show that number. We can't show a point on a number line, this is that number. But in our imagination, we can imagine it. And so that kind of a number is what we are introducing as an imaginary number. Now, why are we introducing an imaginary number? If it doesn't exist in the real world, why go through all the pain of imagining it? Now, although it doesn't exist, it serves 2-3 important purposes. First, it helps you to find a solution to the kind of problem which we asked some time back. So for example, when we said, I have in mind a number which when squared gives you -9. What is that number? Now, in the real world, there is no answer to this. But as we will see, when you introduce the imaginary world concept, then it is possible to put some kind of mathematical expression and a mathematical solution to this question as well. So it helps you to solve that kind of a equation. In fact, we will soon correlate this with something else that you know from earlier classes, which is from the part related to quadratic equations. So very shortly I will be coming to that. But before that, I want to say that introducing an imaginary number is not a matter of just some kind of mathematical symbols being introduced or mathematical numbers being introduced. As you come to certain parts of physics in 12th standard, you will find that in actual real life solutions or real life situations, such as something very day-to-day and very common, the electricity supply that we get at home, you will find that some equations related to that, and so some mathematical parts related to that, and which means a basic understanding and calculation related to that would not be possible unless you introduce the concept of imaginary numbers. So imaginary numbers is not something that is only for the sake of satisfying the ego or academic interest of mathematicians. There is a real world physical correlation to it. Although the number cannot actually by itself ever exist in the real world, some real world situations come up with equations and calculations which require this concept to be introduced in order to obtain a solution. And so, as a mathematical introduction or as a mathematical invention, it is an important aspect. It is an important point that we have to keep in mind. So having said this, let's now quickly correlate some of this with something that we studied in 10th standard, which is quadratic equations. Now, when you studied quadratic equations and solving quadratic equations, you studied the way in which you could factorize a given quadratic equation, the left hand side, and then show the two factors as equal to 0 and obtain the two possible values. But you were also taught one more important way to solve a quadratic equation, something that you call as the quadratic formula, where we said that the possible roots of a quadratic equation, the possible values which the variable x for a quadratic equation in x, the values which it can take, you can calculate those using something called as the quadratic formula, which I'm sure you would be remembering as x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. This is what you have studied as your quadratic formula. So this quadratic formula now gave you two possible roots. But when you express this, you also learned one condition together with this. You were taught that this part which is under this square root sign is called as the discriminant, and you were taught that you can represent it as capital D, and capital D then becomes this expression, or b square minus 4ac, and you were taught that the given roots are represented by this, provided this particular part is not less than 0. In other words, it is not negative. So you were taught that this part, b square minus 4ac, is not less than 0, or in other words, it is equal to or greater than 0. When it was equal to 0, you were taught it gives you equal roots, and when it is greater than 0, it gives you real roots, but it is not less than 0. Now, why was this condition introduced? Simply because if this is less than 0, then this part will be negative, so you will get something like minus 9 under this, the way we took some time back, for which there is no real solution possible. And so you can refer to your 10th standard books again. If you read carefully what is written in the 10th standard textbook, you'll find that the solution to this, it will have real roots if and only if the value of b square minus 4ac is greater than or equal to 0. If it is less than 0, something like this, then you will not be able to solve this because there is no real solution to this. And so, to now make it possible to solve this, we introduce this concept called the imaginary number. Let there be some imaginary number which is the root of this, and that we will introduce to get the solution. So this is how it correlates with that b square minus 4ac part that you have studied in earlier classes. Having said this, Now let's try to see how you can actually represent an imaginary number. We define an imaginary number as the square root of -1. Now, you know that the square root of 1 can be either +1 or it can be -1. +1 into +1 is 1. -1 into -1 is also 1. But +1 into +1 is not -1. -1 into -1 is also not -1. And so this does not give you a real solution. The solution to this is something which does not exist in the real world or in a number line. It has to be imagined mentally only. And that number, which will be the solution to this, that will represent this, we denote with a mathematical symbol small I. We write this as small I is equal to square root of -1 and introduce this concept that the square root of -1 is an imaginary number, small I, represented small I is equal to square root -1. This way you obtain what is called as an imaginary number. Now once you introduce this, let's see -9 का root कैसे आएगा. Now you can say -9 is represented as square root of -1 into 9, which you know can be represented as square root of -1 into square root of 9. And then accordingly, this part can become I and this part can become +3. It can also become -3. And so with the help of the introduction, sorry, this has gone below the scope of the camera. So this I can now write as, this part becomes I and this part can be +3 or it can be -3. And so I can write the answer to this as 3I with a positive sign or 3I with a negative sign. That can give me a solution to this. This part gives me that -1 ka root wala explanation. So this way, by introducing the small letter I as an imaginary part, as an imaginary number, we can take any given negative number and obtain its root in terms of I. Once you have introduced this, some more mathematical operations related to this become possible, calculations related to this become possible, and so those kind of physical world or real world situations which demand something like this to be calculated, you can start the mathematical calculations related to that. That is the importance of this. And as I said, this is not just an imaginary thing. It has real world correlation, right from day-to-day electricity related calculations to complex, more and more difficult calculations, all the way up to rocket science and spacecrafts. We do make use of imaginary numbers. Now, this introduced what we call as an imaginary number. However, we want to go a little step ahead and we want to talk about what exactly is a complex number. Now, a complex number we represent with the English alphabet small z. We have used capital Z for the set of integers. Here we are introducing small z as a representation, as a symbol of a complex number, and we define this as a number which has a representation something like a plus ib. In this representation, this part a is a real component or a real part of this, and this part is representing the imaginary part. So a combination of a real world part and an imaginary world part, which is taken together, that is a complex number z. So a real world part plus an imaginary world part, both taken together, gives you a complex number. Sometimes this part may become 0 and then the whole number will be entirely real. Sometimes this may become 0 and all of it may be completely imaginary. But you can, for general purpose, represent any complex number z as made up of two parts. A real part often represented as a. In short, we often also call this as real part of z, REZ, and this as the imaginary part of z, IMZ. So this is ReZ, this is IMZ, both taken together, real part of z plus imaginary part of z together represent a complex number z, represented in general terms as a plus I. This way, we define a complex number. Now, rules related to the algebra and the calculations of complex numbers, we will be introducing in a subsequent session, but they are very simple, very elementary. They carry on from what we have already known logically, very easy to understand. And then we will try to carry out mathematical calculations related to this. So today we have introduced the basic concept of what is an imaginary number, how you need an imaginary number in order to answer certain particular questions, such as finding roots of negative numbers, and we introduce what is called as a complex number, which is a combination of a real component and an imaginary component, and we defined or we represented it as a complex number is represented as small z equal to a plus ib, where the a part is a real part of z, the ib part is the imaginary part of z. At this point, we will stop this introductory session, and in our next session, take up the further mathematical rules and calculations related to complex numbers. Thank you for being with this class. Goodbye.